Hello there, children. Today we are going to work on Section 5.5, completing the square. This educational experience is brought to you by your squire of squares. That will be me, Mr. Faust. Let's soak this all in and think about what we have to do. Now, completing the square is something we are going to use to force polynomials to essentially be in a certain form that is easier for us to deal with. So, let us begin. So the question is, why do we do any of this? Well, yes, why do we complete the square? Because here's the reason. If I have something like this, if I am able to factor something where it is a binomial squared, I am then able to take the square root of both sides of the problem. Meaning, I can go like this. I can go, alright, that is squared. Well, how do I undo a square? A square root. It's a special case of solving quadratics. I would get x plus 7 equals plus or minus 2, because the square root of 4 is 2, but since I'm square rooting a variable, I need the plus or minus. And then I make these two separate problems. X plus 7 equals 2, and x plus 7 equals negative 2. I then go ahead and solve from there. Subtracting 7 from both sides, I get negative 5, and I get negative 9. Now, the other way to do this would be if I actually FOIL this problem out, first, outer, inner, last, as such, set the problem equal to 0 by subtracting 4 over, this should be a 14x. Now, then going ahead and working from there. But that seems like a lot more work than doing it this way. So it is awesome if I have these things in this form. So let us read through the process of how to do this. So I'm going to show you the entire process here for a second, and then read through every example. So here you go. Take some time and soak that in. Alright, so how do we complete the square? First off, it is a general form of a quadratic. Ax squared plus bx plus c. Now, here is the important thing. A has to equal 1. If it's not 1, I've got to force it to be 1, but we'll talk about that. So, step 1. Get all the x values to the left and all the constant terms to the right. That means you need to move this c value over to the other side of the problem, or the fancy way of saying you're not actually setting it equal to 0. Then you take your b value. Remember, b is the coefficient of x. You take your b value and you cut it in half. Now hold on to that number. That'll become important later. So 1/2 of b. So you take b and you cut it in half. So if b were, let's say, 10, half of 10 is 5. You then take that number and square it. So if your b value were 10, half of b is 5, you square 5 and get 25. So you do that. Now, you add the item from step 3 to both sides of our equation. That means we do that because sharing is caring. Thank you, imaginary voice in my head. So, you add that number to both sides of our equation. You then factor. When you factor, you're going to end up with something like this, where it ends up being x plus or minus a number squared. That's what I want. If you don't, you either pick the wrong number to add to both sides, or you factored incorrectly. And lastly, square root both sides and solve. Well, that seems like an awful lot of mess. Let's go through what that looks like in application, shall we? Sure. So, let's look at a problem like this. So, first step. Get all the x values to the left, all the constant terms to the right. Is that the case here? No! So what do I have to do? That 76 has to move to the right side of our problem. I'll do that by subtracting 76 from both sides. Alright, I've done that. Now, take our b value. Cut it in half, and you hold on to it. Now, we're going to do this on the side here. This does not affect my problem yet. So I take b and I cut it in half. Well, what is b? b here is negative 16. Right there. So I take b and I cut it in half. So 1/2 of negative 16, that would be negative 8. Hold on to that number. Alright, once I do that, I square that number. And what is negative 8, that quantity squared? 64. For the record, folks, the number you get here at all times should be positive. Positive, positive, positive. Then you add the number from step 3 to both sides of our equation. So we go back to our problem, and we are going to add 64 to both sides of my equation. Okay. Gets me negative 12. Now, what do I forget to do? Share here. So what I have to do is I have to add 64 to both sides. Now, one thing you have to remember is you do not combine these. They are not like terms. Then I factor. Give me two numbers that multiply to 64. Add to a negative 16. That would be negative 8 and negative 8, or x minus 8, that quantity squared. That equals negative 12. Alright. I took care of that step. Took care of all those steps. Now we got to factor it. Well, I factored that too. Now I have to square root both sides and solve. So I square root this. Now, when I square root this, remember, I have x minus 8 equals plus or minus, because I need the plus or minus there, the square root of negative 12. But remember, the square root of negative 12, of doing the work over here, that breaks down as the square root of negative 1 times 4 times 3. Why the square root of negative 1? Because that's I. Why the square root of 4? Because that's 2, remember. Because you want to break this down into perfect squares. So that's what that number should look like. And how do I solve this problem, you might ask? Well, how do I get x by itself? Add 8. Very good, imaginary voice. You don't combine these, for these are not like terms. So let's try another one of these. Okay, so this particular problem, get all the x values to the left side, all the constant terms to the right. Well, that's already done for me. Huzzah for that. Now, take your b value and cut it in half. What's the b value here? The b value is 4. So you take and cut 4 in half. Well, what's 1/2 of 4? 2. Now what do I do with that 2? I square that 2, which gets me 4. It is rare that the number you square ends up being the number you cut in half, but that's fine. You add the item from step 3 to both sides of our equation. So I have to add 4 to both sides of the equation. Hooray for that. I do it to both sides because sharing is caring. Thanks, imaginary voice in my head. So I add 4 to both sides of my problem here. And then I go from there. So now I have to factor this. Now here's what's awesome about this. Give me two numbers that multiply to 4, but add to 4. That would be 2 and 2. Or x plus 2, that quantity squared. Now, if you do this right, folks, remember that number that we cut in half, that b value. What would that be? Well, when I cut b in half, I got 2. Isn't it a funny coincidence how that number that I cut in half 2 is the same number I put in my binomial? Is it a coincidence? No. No, it's not. That number you cut in half will always go right in your binomial, in case you want a little trick for factoring. Let the rejoicing happen. Now let us square root both sides, because I have factored it. Now when I square root, remember, I need a plus or minus. Now, I do not expect you, off the top of your heads, to be able to tell me what the square root of 3 is in a decimal. It's not a whole number, and it doesn't work out to have a whole number in it, so we're good, as the kids say. And how do I get x by itself here? What exactly do? I subtract 2 from both sides of my problem. I do that because sharing is caring. And there we go. There's my final answer. Now, how does completing the square help me over factoring? Well, let's say I set this problem equal to 0 and I add 1. Give me two numbers that multiply to 1 and add to 4. They don't exist. This thing clearly has answers, but those answers wouldn't be things I would be able to factor. So we talked about limitations. Factoring has its limits. Completing the square will help us out, but it will also have limits. So, let's try another one of these. Alright, there is an issue with this. Alright, so what? Get all the x values to the left, all the constant terms to the right. I get as I go along there, but wait, there's a problem with this. And now to hand it off to a teacher who's much better than me. Wait.
Hello, this is Miss Brilla. I am not friends with Mr. Faust. I am now going to complete the square. So I first need to look at this, and that 2 for the A should not be a 2. I have to divide that out. So I have 2. Whoa. Mr. Faust, I am not fond of your... Wow, I have classic music playing right now. Huh. Alright, if I divide out the 2, I now have x squared plus 6x. I'm going to leave a space just because that's what my high school teacher told me to do, so I do that still. So I leave a space, and in that space I'm going to put my new c, so I'm going to take my b, divide by 2, and then square. So I've got 3 squared, which is 9. So I'm going to put a 9 in there. However, it's not really a 9. It says a 9, but this is really an 18. Crazy. So now if I'm adding an 18 on the left, I obviously have to keep it balanced because this old equal sign says that I have to. So if I'm adding an 18 in here, I need to add an 18 in here. Is that how you're showing them? Or are you subtracting it on this side? Are you sure? Okay. You were dividing by 2? Oh, okay. Let me take that back. Are you sure? Okay. This music is really throwing me. I don't know that I can do this. Okay, so if I put an 18 in here, I have to also add an 18 in here because I gotta keep it balanced. So then I now have 2 times, and if I factor this, do you go right to x plus number squared? Okay, so I have x plus 3 quantity squared. This is now equal to 4 plus 18, 19, 20. Okay, so 22. Then you want me to solve for x, right? So now I'm going to divide both sides by 2. But I always have to be nice to the other guy. Do the same. So I have quantity x plus 3 squared equals 11. But I got to get rid of that square root sign. However, I'm choosing to write the square root. So I need to also account for a positive negative on my right-hand side with that square root sign of 11. I cancel out the square, so I have x plus 3 is equal to positive negative square root 11, and then I gotta subtract 3. I need way more room. I'm gonna squeeze it right there. Mr. Faust, you're gonna regret that you ever asked me to do this. I am making a mess of your notes. Yeah! I hand it back to my non-friend, Mr. Faust.
Now, the other thing you could be asked is this. They could say, alright, I have x squared plus 20x plus c. And I'm asking you, well, I want to know the c value, which would make this what is called a perfect square trinomial, which, if you recall, is just x plus or minus some number squared. And I want to know what that would be. Well, how the heck am I going to get that? Well, folks, you've been doing that the entire time. You just haven't known it. What you do is you take your 20 and you cut it in half. You are then going to square that value. Now, how is that going to help me at all? Well, if I put 100 in there, for C. Give me two numbers that multiply 100, add to 20. Well, they are 10 and 10, or x plus 10, that quantity squared, because the two numbers we just figured out were x plus 10 and x plus 10. Well, the question will ask you, well, what is C? C would be 100. And what is your binomial? There it is. There's my perfect square trinomial. Let's try another one. Hey, look, this problem. C would be 25 because you cut 10 in half and get 5, and square 5 and get 25. And x plus 5 would be your factors. Now you are ready to attack all of the sample problems right here. Look at all these wonderful problems. Go henceforth and work on these particular problems. Find the value of C that makes the expression a perfect square trinomial. Then write the expression as a square of a binomial. Remember, that's just this. We just talked about that. Beware these. Ooh, fractions. But fractions are our friend, not food. Go henceforth and do.